Hello, everyone. My name is Maria Braun. I'm a .NET developer. I'm currently working on a project that's devoted to online learning. And I would like to introduce our next speaker. It is Raffaele Rialdi. He's a senior software architect working as a consultant, a speaker, and a trainer. And is, of course, an often guest at .next, and we are always happy to see him here. He has been Microsoft MVP since 2003, and he is an active participant of .NET community. So today, Raffaele is going to take on a really interesting and useful topic of model versioning in distributed systems, where he is suggesting a new approach that's based on code generation, and hopefully it will help us to overcome the versioning hell. I would also like to remind everyone to ask questions to Raffaele in the chat. So, Raffaele, please begin.
Hello, welcome again to one of my sessions and .next. I am so happy to be part of this conference. And if you are a long time attendee of this conference, you will remember probably that my very first talk here was about code generation. And this is interesting because I work with staff, also with my consultancy a lot. And I mean, this time I really have something super useful because instead of talking about the technical aspects of code generation, we will talk about real use cases in the architecture environment. So this is a very interesting stuff because I want to resolve one of the big problems in software, that is versioning, and is in a particular environment, let's say, with specific constraints, but we will see if you like it, and I would like to discuss with you in the discussion zone later on the details of this. If you give me an okay, Maria, I will start with my session.
Yes, start please.
Okay, so let's start. I mean, welcome again to my session. This is a very special topic for me because it's something that I'm working on since quite a long time. And I really wanted to understand how to resolve a problem that a lot of customers came to me and asked, how can we maintain online our services, maybe in a microservice architecture, without having to reboot them when we make some changes to the public model. So basically, we want to be able to change the public model without having to disrupt the entire infrastructure. I will show you specific use cases in order to understand better the scenarios that can be resolved with this idea. Maybe more. I mean, maybe there are others that I didn't think about. So I am Raffaele. I am a senior software architect. You know me from past versions, so I will not stress you about the other things. I wrote a C# book, which is something very special with a couple of friends. And yes, I'm part of this great family of MVPs, and I miss absolutely traveling around the world, in particular in Russia, but also in other cool countries. So the agenda is we want to resolve the versioning in REST-based services. There is no really a reason to limit this thing to REST services, but all the code that I wrote and that I will show you is specific to REST. So let's basically start from there. So instead of showing you all the pieces and start from the building blocks that makes up all this idea, I start from the end. So basically, we start looking at the scenarios that I believe they can be resolved using the semantic driven modeling. And then we will see how it's possible to practically build these mappings between two models that are different, because I have a conversation across the services, and I have two different models, because one of them has changed, because it's something that has been evolved for a lot of reasons, and I want to map them. And then we will dig into more detail in this machinery that I created. Of course, there is a big demo. We will not be able to see all the details because it's a lot of code, but we will also have time in the discussion zone eventually. Let's start. So the main scenarios is that we have services, but the focus point that I want to open is not just the endpoint, because if we think at the endpoint of two services, basically you can get rid of the problem in versioning by making an HTTP redirect. There are many, there can be a proxy, there are many possible solutions. But the data that passes by this service is something that you have to deal with during versioning, and that's the big problem. So let's make an hypothesis that we have these two models, and here is the first route, which is the order, and you have a one-to-many with order items. And then there is a one-to-one with the article, and another one-to-one with the company. And then again, another one-to-one with an address. And let's say that another service that is a reporting service, for example, has its own model that has this shape instead, which is much simpler, just a single one-to-many, nothing more, and so on. Or maybe you want to simply, in another kind of scenario, you want to upgrade this model to this one. For some reason, you decided to entirely change the structure of your public model, and are afraid, of course, to disrupt completely the consumers. Okay, so there are many possible use cases. And the very first one is, and I believe this is the easiest, but not necessarily the most interesting, when one service wants to update its own public model. So you have a lot of consumers, you have the cloud in the middle, there are get and post, so you can push data, get data, and so on, and you have this service with model 1. And this version 1 has some problems. Maybe it's just refactoring. Maybe you want to add some features. And as a matter of fact, you usually upgrade this one with new endpoints, maintaining the new old model, because of course you want to be able to continue servicing the current consumers, but you want also to expose the version 2 of the model, because before or later you want to obsolete the first one. So this upgrade is problematic, because if you are in cloud, for example, you have to prepare on the dashboard the different endpoints. I mean, it's not difficult, but it's something that can cause some annoying glitches. Otherwise, you have to redirect, as we said before. There are a few things that, yes, you can do it, you can test it, but it's not that practical. And the most important thing is that when you exit with a different version 2, your code is going to be very complex, because you have to provide maybe different controllers, you have to provide conversions, maybe your internal model, the one that goes with entity framework, it's not that easy to test and copying in with version 1 and version 2. There are multiple issues there. So the proposal with the SDM is just to say, okay, I want to upgrade just to version 2 and forget and delete version 1 from my code. I don't want to have the version 1 anymore. So I just don't care about the external users anymore. And I want to be able to produce the JSON for the model 2, as well of the model 1. So that said, we can say, okay, we have a service with .NET code that is only able to read and understand version 2, but there is something in the middle that uses some kind of metadata, and then we will talk about this later on, that is able to convert this model 2 with these types directly into the JSON of model 1. And also, of course, is able to make the straight serialization that you would expect with version 2. So this is the normal serialization, and this is the one that SDM can convert. And all the conversion can, in this case, happens on the server. So you have full control and you can test it, you can validate them, you have nothing to do. And the service code is so much simpler, of course. You still don't need DTOs anymore. And this is important because these DTOs can be quite complex because we are changing a lot in this structure. You are able, in fact, to change the data types. So we will have to produce converters. You are able to rename the properties, but you are also able to change the shape of the graph itself. So it's a lot of things. In a second scenario, let's say we have IoT devices that are publishing data, and so you have version 1 of this device that is pushing. I mean, you don't want to really have to add anything on the device. So in this case, we still have the ability to make eventually the conversion on the server side because we don't want to make for example, an Arduino aware of the SDM. So we want to stay as low as possible, and these are simply devices. But as a matter of the fact that you will have more devices that are coming, in some cases you can still have version 1, but in other cases you will have a new model because, I mean, you have additional temperature, you want to provide more location data and so on. And then you will grow up and you'll also have version 3. And supporting all of them without having a smart conversion here is frankly quite complex and can bring you a lot of difficulties, especially when there are many hundreds of devices. And so the idea is saying, okay, I want to provide an SDM converter that is able to deserialize from any of them straight to a single model, the one that this service care about, okay? So it's a straight conversion from JSON directly to this model. And another scenario, which is quite typical in event sourcing or where you have a bus, a queue, or whatever you want, is that you have, let's say, for example, CQRS, and you have the right channel, and that has a specific service model, the one that you use in order to keep the slices of the differences that you are want to that you want to make as changes in the system. So basically you have these commands that contain pieces of the service model and the model that has to be changed, and you enter here and you store all the slices so that you have this transaction log that say of your system with the changes to the order lines and whatever else. You also replicate this data to a relation database so that you can query with entity framework that has its own model, and then you publish it on the reading side. At a certain time, of course, you will have to change some of that. And so if we have the necessity to change something on the right channel, again, you can use the SDM converters in order to normalize, let's say, so convert this new request to the model that is current here, but you also gain the advantage to be able to retrieve the old slices that are with the older models. So inside the NoSQL database, you have the serialization of the old commands that has the old structure, and this is a problem, and you want to be able to deserialize them using the new one, because of course you care about your business logic has been upgraded to work with this, and you cannot change the old slices. You will never want to go and change the historical data here. On the reading side, instead, you want to support multiple reading models, which is quite a common request, because there may be, the main reading model that is the one that has the same shape of entity framework, but you may have other reading models that has other purposes like reporting services or searching or specific exports for other systems and so on. So this is important to be able to support multiple reading models without having to support the models inside your service, but you just model the mappings and you produce straight from your internal model to the JSON of the reading model the client is expecting, and nothing more. You don't have to have all these models in as code, as type inside this guy. And this is extremely important. So these are the scenarios, but probably the most interesting is when you have a microservice-based architecture where you can expect a lot of services. I mean, several tenths of services that talk to each other is a kind of complex graph where they call each other and so on. And so, of course, if this service is going to upgrade and to update this model, you will affect the consumer, right? This service tree. But what happens when you have multiple other services that you are affecting? They are all consumers making gets from the model, so the data is going left to right. And what happens is that as soon as you publish the new version 2 here, you will affect all of them. You basically have to redeploy everything, which is unacceptable, right? So you will publish other endpoints and so on. Instead, my solution is that you can simply add this SDM layer that is able to convert between the two, and you are able to make tests on the fly as soon as you are developing the solution, and you can just publish the metadata to these running services without the need to reboot these guys. So you will, of course, reboot this, because if you are upgrading the model, you will need to restart the service 1, but not the others. The point is that you don't need to restart service 2, service 3, and before. So how can we map these models? The mappings are quite complex, and you can see with the arrows that there are relationship that goes beyond, because we have order items and then one-to-one here, one-to-one here, and on the other side, the multiplicity is different. So this, but yes, I can say you that it's definitely possible because I did it. And here we have another good example, which is I have product name here, but you have to be very smart, I mean, to understand that this article.name means a product name. And so we have to find something that is a kind of human intelligence that understands that the article name is product name, and this name is not a name in general. It's not an order name, because order name and article name makes a difference. We have a context here, which is the name of the class, and we have to use it. And then also the conversions among the types. So we have datetime here, we have datetime offset there, we have decimal here, and we have doubles here. Okay, so it's totally different. You see here how many relationships we have to cross to reach street, city, and state, and instead here we have just a single one-to-many. So this is something extremely complex, of course, but I wanted to go beyond that. I want to build the automatic buildings of the mappings, because, of course, if we ask, I go back from our slide, if I ask to one person, to a developer that should write down with the pen the mappings between these two models, it will take some time. I mean, it's not so easy. It's doable, and it's definitely doable. But you have to read everything, understand the meaning, and understand the concepts. So the main idea is that we can rely on a semantic analysis. The semantic analysis is the art of understanding what concept stays behind the things that I am reading. And unless I have a full documentation, and in software we know that we don't have documentations, and unfortunately, and we know that the best thing that we can do is reading it and understand that this name is related to the article, that this description is related to the article, and we have a context, but we can do it more. So from the article, as a word, as a term, we can understand it as a product. And this description is a human representation. The name is an identifier, but the ID is a unique identifier. And the expiration date is a point of time. How can a computer know that? We basically have to give the computer a vocabulary, of course. We have to provide all the terms that are relevant in our specific domain of business. We don't want to fall in the huge problem that RDF and the OWL had when they tried to resolve this problem from a different perspective. So they tried to resolve the universal problem, giving a universal schema with every possible domain, with every possible thing. The result in RDF is that you have to provide a schema, and you have to provide a specific piece of metadata that describe the things. Instead, we want to deduce, which is different. We want to extract the metadata from things that you normally code with your hands, and you don't have to bother to make additional metadata. And we don't want to even put attributes, because the attributes for the purists are bad, and I can understand that. So we don't want to even be .NET specific, because we may have different services written with different languages, right? So this is the main problem. We want to preserve the context for the navigation, for example. We want to understand the deep meaning of that. In order to make that, I decided to create a small language, a domain-specific language. And this language is extremely simple because it's just a file of text which provides this one with the $sign is a comment, basically. It's for humans in order to understand, but there is a code generation behind that I will show you that will produce the description, so that we still have this piece of information in the code if we want. Then we, let's say that you want to start with your own model, and I give you a tool that grabs all the terms extracted from your model. So basically we make, with reflection and analysis, we take all the terms, and when you have a long list of terms, how can you produce this file then? Well, it's simple, because you have to group the terms that you extracted from your model into concepts. What does they have in common? Of course, the weight, the net, and the gross, and the load. Load is quite vague as a term, is referred to unit mass, and this is a concept. So for this concept, we have a lot of possible alternative terms, but they are not exactly all equal, because of course the net and the gross are very different. And so for this reason, we have specifiers. The specifiers is a kind of second level concept that can give you an additional hint, so that you say, okay, this is a unit mass, but it's a net, it's not a gross. So you don't want to map a gross with a net, because of course it's bad. And then also, since this term in general is quite vague, I mean, you don't know exactly, can be loading a file. It doesn't have any relationship with unit mass. But if it's related to a product, if it's within a class that is named product, or in the graph, in the parent connection, there is a product, it may be a load in terms of unit of mass. And this is the idea. Then we have some weight, which is good in order to have some kind of weight to make the calculation of the relationship. And of course, again, descriptions that are comments that you can add to these terms. Okay. And if we come down to our slide, write down your business glossary in a text file. It sounds DDD ubiquitous language, right? So Eric Evans, when he first wrote the book about the DDD, specifically told us, please try to use specific terms that are meaningful inside your domain. Please don't use, the very old days, if you're old enough, you will remember people writing variables with A, B, C, D, and a class that is B for base and D for derived. Oh my God, that's bad. I don't want to even try to map a model like that. I want to be driven by the semantic of a model that is meaningful for me. So if we respect this kind of message, so to use a ubiquitous language, we can extract metadata that are meaningful from our model. This means that SDM is not targeted to map an arbitrary service on the internet like the GitHub one. Maybe it works, maybe yes, why not? But this is not necessarily true. It can be true if you are working in the same domain, so we can share the same concept, the same terms, and so on, and the domain was planned carefully or adapted in the time carefully, because if you use the correct terms, yes, it can be done. So basically in SDM, this step of the DSL is a kind of formalization of the ubiquitous language. Okay, and how are you writing down your model? Because if you want, you can still write down classes that have A, B, and C, but I will strongly suggest to do differently. That's it. This is the kind of slides that I would like to be in person in front of you, because it doesn't make sense to smile in front of a camera. And then, so the SDM domain elements, what else is there? We already talked about the concepts, the terms, the concept specifiers, and the weights. The domain is the one that links everything together, okay? And I want to show you exactly what I mean, because if I show you this, you will see that this ERP domain is the text of file that is described before. You see there are comments here. So it starts basically from here, okay? And the structure is exactly what I showed you before. And you see that this class has no code at all. And say, how can you do that? So I used C# code generators. Yes, the very latest C# code generator. And these are, the analyzer is here, and you can see the semantic glossary generator. And from this text of file, I generate 4 different classes. The first is the one with the terms, which is generated with Roslyn, okay? So it's very simple, but we have all the terms here. You see, here the list is very long. If we come back to the text here, the list is very short. So it's so much convenient to write down this one. And then we have the concept, which is shorter, of course, because there are less concept. And nothing terrible. You see, if there are comments, I can put it there, also here. And then we have the concept specifier, which is also much shorter. And finally, the domain. And the domain has these links with a name, which identifies the domain, and all the links that pulls the relationship between the concepts and the terms and all the rest. And this is this is the DSL. So you don't have rules, ifs, or loops on and everything else. It's just a declaration of a lot of things. And we can go back to the slides. In the domain class, you can derive it or a partial class so that you can add side by side and add the policies for example, the measurement that you express in your domain are all in the international system and not the imperial one. This is something that can be shared across the whole domain. You don't need to absolutely take half and half, no? But I don't want to describe in the DSL this requirement. It will be stupid because we are talking about something that is domain specific, and we can make assumptions, and assumptions are good because it allows to do less work. And since we share this knowledge, let's do it. So we can formalize this in order to put eventually the code that is needed to make the validation also for the policy. And then we have validations. The validation is something that is important because we can make an analysis like running a test, the unit test, on the structure of your domain model. So for example, when you have this system and you have the validations in place, you can build a unit test that says every time you declare a property which is associated to a concept of kind weight, this should be expressed using the decimal data type. And if someone tries to create a new weight property, which can be also a different name because we have several terms which match the same concept, is matched to a double, for example, you will not have the test pass, and so you will not risk to invalidate our domain. So this is another aspect that is extremely interesting. And also you can put in place also rules, and for example suggest the automatic mapping to say, well, every time you have you find a unique identifier, please map it only with other unique identifiers. Don't map it with a string, for example, with a name or a description, which is good. I mean, this is one of the default rule that I put in place, but you can add more if you have something that is specific in your domain. There is another important aspect of all this stuff, which is, when you go to a service, you of course have to show to expose the data so that you can negotiate the versioning. How can you negotiate it? So I will show in a moment the code for the formatters that I created to negotiate the version. The basic idea is to rely on the standard HTTP versioning using the accept content type, of course. And so the type is, of course, application. I remember you that the application/JSON is the default for most of the web APIs, but you can still add some subtype. And the subtype is up to you. I mean, is something that is normally domain specific. There are standard subtypes. There are X- subtypes that you can create in order not to register one. Maybe one day there will be some SDM dot something in place in the official registration, and we can use something that is SDM dot the domain name, which is, by the way, exactly the one that I declared here, okay, which identifies this vocabulary, let's say, okay, that I create in code, and then it is also formalized in this property, okay, and also the type system ID. And the type system ID is important because depending on the type system that you have, and that represents the version of your public model, of course, things may change. So with the same domain name, you may have multiple versions of your entities. And before digging in the rest of the slides, I want to show you what I mean by type system. Of course, we have to make a little step backward and say, okay, I showed you the domains, but how can you do this work? And practically, you may had some doubts about the fact that this can work cross-platform, because you rely on types, you rely on data types, you have decimal and doubles and so on. So when I first write this stuff, I wrote the code for .NET, and then I said, wow, I should extrapolate all the information that is specific to the description of the model in an agnostic way. And so I create this surrogate library, which abstracts the type system. And the type system basically is able to describe all the types. So we have, for example, the surrogate type, which is able to describe what we mean a type in .NET. But of course, exists the same concept even in other language. Okay, so you may work with Java, with C++, and so on. Not all of them support reflection, okay, with introspection, let's say, but you can do the same things using the source code. C++ can introspect the source code, and so not at runtime, but you can do a nice job with Clang. And also you have surrogate properties that represent the fields, let's say, because we have properties, Java has fields, but it doesn't matter. It's basically the same concept. And the nice thing of this type system is that it's serializable. And so I can create metadata. And as you see, there are records, so classes, but they can be compared. And this is so nice because you can really create also unit testing so that you are sure that they match the one that you loaded with another one, what are the differences, and you can understand what's in there. And of course, in order to avoid circular references, because the type system has graph that goes also on the parent, I had to create the links using integer. But then there is an interesting method which is update cache, which is able, let me see if I find it, okay, which once you have the serialized with the number, you just call this one, and it creates all the links so that you can navigate the type system freely without having to rely on a lookup table, basically. So this is everything you need to work with the abstraction of a type system. And of course, this is important because every time you give a version name, a semantic name to this type system, you know that you are relying on a specific version of your model. And this is what I have put it here, okay? And once you have in place the service that is running with this, of course, you want to be able to request different version. And this means that basically every time a client will ask for a different version, what has to do? Simply make the question, and if the metadata that allows the conversion is available, the converter will be able to make the appropriate conversion, eventually loading from file the mappings. So you don't even need to restart the service because we don't rely on the system type and the property info and all the reflection types. In addition to that, and I will show the code in a second, we also have the production of the Open API metadata, because it's important that the client knows that on the other side, you can both produce the order, but even the online order. And so having this choice, you want to know how they are, what is the shape of those types. And this is extremely interesting. By the way, this kind of work on the Open API is an ongoing process, but it already works with the content type. I will show you in a second right now by running this API server. This API server has the controllers, And the weather forecast is of course commented because it's the one where I started from, and this is not used at the moment, but you can guess that this metadata controller is the way to expose all the SDM metadata with a specific endpoint, like OpenAPI do to expose the metadata for REST currently. We will just focus on the order controller. We just have a single controller order because we want to stay with just one single version. We have a fake repository service, which is a memory service, and it's not really important. We have the ability to make a get returning all the orders, and we also have the ability to post, and we will print out on the console the count of order items that we find. Okay, so this guy is only able to deal with orders, but the client can also deal with online orders. By the way, in order for you to understand the shape, the order is the one that has order items. Now I started my API server, and my API server just start this solution and show me the OpenAPI page where I can do a lot of things, right? I can do get and post. And if we look here, we both have order, but also online order. And by the way, I don't even have the reference for the online order. There is not, this type is not here. This was created by means of the semantic driven modeling metadata, okay? So I have this get order, I can try out, okay? And if we request the order, well, of course it works. We can request the order and I have the order items. That's all fine. But if we change and we go to the online orders, we see that this is the type system version 2. Well, if I repeat the execution, look at here, order items, okay, execute, and we jump in this place. And what is that? This is the place where the semantic converter happens. What is the semantic converter? Semantic converter is a JSON converter, a system.text.json custom converter, okay, that is code generating all the conversion. So it's not something that is done using reflection. We use only reflection to generate the code. But once the code is generated and opla, we generate the code, we have an expression. So on the domain specific language, we use a Roslyn. And now we have link expression. So we have a full techniques. And you can see here that we have the exact code written using the link expressions that not only converts the model, but they convert also the data type using the conversion library, so that the time offset can be converted to date and the double can be converted to decimal or vice versa. And we are, everything is strong typed. We don't have boxing unboxing operation. We don't have any new that is not strictly needed. It's a straight conversion specific to this model that is done only once. And once you have all this code created and you see right object, okay, by the way, this JSON converter cares about the entire tree, okay, not just the order, but even of the related entities. We can compile it and run. And so the second time you see that we skip the generation. We don't have this generation executed anymore because there is a dictionary. And finally, we get here not the order items, but the order lines, which is the other model that I created. And I obtained magically the conversion of everything I needed here. with the conversion of data types, with a different structure in the graph, and so on. So this is it. And we can do more, because I can just copy in the clipboard this response. Then we go to the post. We try it out, okay? So I just select everything, delete the content, which is the example content of the OpenAPI, I Control-V, and paste the one that I took from the get, okay? And I want to post order lines. I have to specify the content type, of course. And you see order, online order, that's right. So I can proceed. And you can remember that we had few diagnostic things that we need to get again in a second, okay? Execute. We execute, we have all the types that has been sent, and if we come back here, we see the console write line that I showed you in the controller before. So we have the full get and post. And of course, if you want to put patch and whatever else, it's just a matter of implementing it, because it's the direction that makes the difference, okay? And this is so nice. By the way, this is the informal output with the matching, the mapping that I did. And you see that inside the order line and the order lines street, the map is string to string with the order item customer address street. Okay, so this is the map. What else can I say? This is, I'm very happy about this. And one thing that I would expect from you guys is that what about the performance, right? Because it's something, so be patient, because we have a specific stuff there. But before of that, I want to mention one thing that is extremely important, GraphQL, because I bet that someone of you has this GraphQL in mind, which is a wonderful thing. It has a nice grammar to specify what I want to remove from my graph in order not to put a lot of data inside my channel of the HTTP channel. Well, you have two options. You can use both. There is nothing preventing GraphQL from being on top of the request, of course. But remember, GraphQL does not change the graph shape. This means that you don't have the same machinery. It's just to remove stuff. And I can also say, well, if it's just to remove some property out of it, why don't you use SDM only on the server side, and then you just remove the mapping? Because if you remove the mapping, my converter, of course, will not copy the data. And this means that you obtain exactly the same filtering that GraphQL has. So this is also a point that is extremely important, okay? Then I also promised you to show the code for the conversion. And I can say it's extremely complex, but the conversion library is pretty dumb, because you can see a lot of converters, and I basically have to convert the basic data types only, okay? So when you, if we go back just a moment here, okay, you will remember, okay, this graph. If we are here, you will notice that we never have to map the article, for example, because the article is just a complex type. We have to map the leaves, okay? And the leaves are always of a basic data type. So we don't have to care about complex types. We only have to convert the leaves. Okay, we can go back again. And these conversions are basically the ability to convert everything to everything. So if we take the to-string conversion, if the destination is a string, I can convert from, and then from a byte, what can I do? Value to string, of course. And there is a specific format provider which you can hook so that if you want to provide a custom format, you can do it. And then, and on and on and on. If I want to go to int 32, for example, and I come from, let's say, a string, okay, you basically have a try parse, but with all the hooks and providers and styles that you may imagine. Okay, so this is the kind of conversions. The most important thing is that you have to call this in a typed way, because if we want to go to the string, let's say, and we want to use this one, I don't want to unbox when I come here. This is why I use code generation, okay? That's super important. I come back to the slide, and I can say you that I'm very, very proud of the work that I did with benchmarks, because if we just look at the standard system text JSON serialization of the order, so the model that was on the left on the slide, it takes like 9.7 microseconds. If we just make the conversion of the plain online orders, so the model that was on the right, I obtain a better performance, of course, because the graph is smaller. There are just 2 classes instead of 5, 6, okay? So that's it. But as soon as we convert from order to online order and I use the mappings, I have a better numbering. So 6.1 microseconds, or in the opposite direction, 6.0 microseconds. And you can wonder, how is it possible? Well, of course, it's code generated. That's it. So this is entirely code generated, and I code generated not only the order. I don't have like 5 or 6 converters. I have just a single converter for the entire tree. And that makes an enormous difference, because you don't even re-enter in the internal machinery of system text JSON. You go straight and serialize everything that is in the tree. In the opposite direction, you know that the serialization is trickier, is much more difficult, because you have to follow the order of the JSON tokens, and they can come in any order. So you have to be prepared in the serialize everything in whatever order it comes from. And the deserialization happens that it's slightly less performant with the mappings. But let me say that I am super proud of this, because it's just roughly a factor of 2 times is definitely a great result. At least this is almost 3 times, but I mean 2.5, 2.8. That's great. And I made a test, and I tried to put in place a version of the mapping that is not using code generation. Frankly, it's not possible, because there are a few things that cannot be done using reflection. So I had to use expression in a few cases. But the amount of work is 3 orders of magnitude. So times 1,000, it takes longer to make the conversion. So this is definitely something interesting, because if you think in a microservice architecture, you definitely want to have a great experience there. You maybe have 1 hop, 2 hop, 3 hop, and if you lose time in converting here with the converters, you are lost. Because many people, for this reason, rely on gRPC, which is, okay, a pretty good solution, but makes your code to maintain very, very much uglier. Is terrible, because you are strictly tied to that specific version of your model. It is even more difficult to advance in the versions. And by the way, is this applicable? Is SDM applicable to the serialization of gRPC? Yes, it's possible, but it means another huge piece of code. So definitely it is possible, but it's something that is too much for the extent of now. And what can I say? I want to thank you for your attention. I really expect questions because, this is something that you will not find across the internet. I plan to publish quite soon the code as well. So you will, before or later, if you stay tuned on my Twitter account, which is this one, you will find that I will publish the announcement of my publication there, and I have done for a moment. So I want to have some feedback from Maria at this point, right?
So thank you very much. It was really interesting and useful. Especially, I was impressed by the part about microservices because I have worked a bit with them and I know the pain of
Yeah.
what you were talking about. So it would be nice to have an option to somehow deal with the versioning, because yes, when you have multiple
Definitely
microservices,
yes.
it's hell when you need to update a lot
And
of things.
I had a
It's
confession to do
terrible.
because I said that this topic is super special for me, and I want to, for the first time, to announce publicly that this is the topic that is in my dissertation, because yes, I am going to graduate on December in the master degree of electronic engineering, and was the topic that I am going to present at the final presentation in December. So this is my first time that I disclose this. This is nothing for you all. I understand is my own satisfaction, but I am so proud of sharing this with you.
So there is a question in the chat. First of all, do you have any blog posts on the subject?
Not yet, but as
Are you
I
planning
wrote
to?
an entire dissertation, by the end of December, I will publish the dissertation entirely. So there will be a lot of explanations there.
Well, dissertation is might be a bit too much for us simple mortals, you know.
Well, yeah, I will probably, I mean, just the introduction, which is in the, I was asked to write a full introduction with full explanation there. Yes, it will be published and will contain the whole point. But I also plan to add. I didn't publish the code yet because I want to add more README to the code so that it can be better understood.
Okay, so another question, not sure I understand. So the question is, what about the combined fields if you have like full name equal first name plus last name?
Combined fields. So
Is there a
we
way to map?
usually, so you mean that you have not simple properties, but complex properties where you have some calculation, some multiplication, addition, and things like that?
Probably. I think we can get the details in
Okay.
the Zoom later. Yeah.
Okay. One important thing to remember is that for the entire talk, I said the public model. So usually you use DTOs for that, where you don't have any logic. This is not in something aimed to resolve the mappings of internal models, where you have business logic, methods, and like property changed fields and things like that. Maybe it works, but this is not my primary intent, because of course where there is some logic, you cannot do anything. At least you cannot express with metadata some kind of formulas or other kind of complex thing that you can do on the mappings. So this is one of the reasons why I relied only on the JSON serialization. So basically, the entire point of the implementation is to convert the model into JSON or the JSON into the model. And this is aimed to be on the boundary. And
Okay.
it's extremely important because you avoid any other copy or things like that.
Yeah, that makes sense. Okay, questions keep coming, but I think we need to wrap up here and move to the discussion zone so that
Of course.
people can elaborate on their questions more. I think it's easier. So thank you very much for your talk once again.
Thank you.
So, yeah,
See you in the discussion zone.
see you in the discussion zone.